All right. So far we have discussed about descriptive statistics. Last time we were discussing about standard deviations, and also for quartiles and quantiles were left. So the thing is, let me summarize all the things so far we have discussed. In descriptive statistics, we have seen the characteristics s- of the data. That said certain things we have seen. What were the characteristics? These were central tendency, variance, outliers, also change over time. We have discussed these things. So the main thing is the central tendency. Central tendency gives you that where is our data centered at. The only thing is, because once you have a data which is in a raw form, how you can make sense out of it. For this, you need to know that how your data is spread around the mean, or how does it look like, what is its shape, is it bell shape, or is it like standardly distributed, or like what is it, a kind of symmetrical distribution, what kind of distribution look like, and how you can summarize it, that what is the percentage of data lies in which section. So this is very important for us. The central tendency is important because you need to find the center. The mean tells you that where is your what is the average distance of all the values, because it counts each of the values in your data sets. This is why it affects by the outlier values. When you look at the median, so median tells you where does your data centered at. It does not affect by the outlier value, because it doesn't count the maximum value and the minimum value. And when you talk about the mod, so mod is that the highest occurring value in your data. If the data value is occurring 2 or 3 times and the other values are not, then the mod will be the largest occurring value in your set, that is called mode. So the next thing comes out, standard deviation. Why standard deviation is important? Because it tells you what is the average distance of each of your data values from the mean. So this is why it tells you how many jumps it can have in each of the data value around the mean. So this is why it is important. So after standard deviation, when we know that what is the average distances of each of your data values from the mean, then it can help you to understand that how many percentage of your data lies in which section of your graph. Because we are summarizing the data, we are seeing it graphically. How does it look like? When you see it in a graph, then it is very important for us to know that where is your maximum data lies. Is it on the right side, is it on the left side, or is it at the center, or it is symmetrically distributed? So for these things, Chebyshev's theorems was important, because we discussed about that how many percentage of data. Chebyshev's theorem is applicable and is more general form, because it applies to all type of data. No matter you have normally distributed data, or you have left skewed data, right skewed data, or uneven data. It could be in any form, but it can tell you what percentage of data lies in which side of your mean. Like if you take one standard deviation, then 75% of data around the mean will lie on it. And if you have the data 2 standard deviations away from the mean, then overall 88.9% of data, and then so on you can find. And there is a formula for it. You can find it out, that 1 minus 1 by k square. It gives you the proportion of your data lies in k standard deviations away from the mean. So K was basically the jumps you take. So the difference, I told you that K, if you find the K, that means you are finding the upper limit and minus the central point, which is mean, and divided by standard deviation, that is giving you the value of K. But when you find the Z score is the same thing, the number of standard deviations away from the mean. But the only difference is that Z score, it doesn't matter the values on your right side or the negative value, it is the count of jumps around the mean. So this is why Z-score is important, because it is applicable for all variable, like I was discussing last time was Lyndon B. Johnson's height. So he was a variable. So X I took with him because we were talking about his particular height. So that was X. And then you subtracted from average height of all the people and divided by standard deviation. That is giving you the Z score. So Z score is important for you to compare your data, to compare you amongst all the sample spaces, that how your score, like you scored something in mid Michigan college, and your friend is getting scored in Lansing Community College, then how you can compare yourself with someone's. So the only topic was left last time was quartiles. Quartiles is a key percent, percentiles. Quartiles mean comes from quarter, that if you have data is spread, how you can make quarters of your data, so how you can divide it into parts. So this is why quartile is important. If you take the first percentile, and the percentile is you make your data in an order, in an increasing order. So the bottom 25% is your first quartile, and Q2 is the bottom 50%. So if you are taking 50%, so it means the median of your data is second quartile. It partition your data into two parts, one on right side and one on left side. And Q3 is the bottom 75%. It means from increasing order 0 to 75%, it is giving you all the values in between. So that is our Q3. So this is what we were going. And Q4, it covers everything. 100% of your data is Q4. So these are the quartiles we will be looking at. Here was an example. Or this is in interquartile range. It means what is the mid range of your value, the middle half of your data, where does it lie? So between 75% and 25%, how much data do you have? So it is half. If you subtract 75 from 25, then it is giving you 50%. It means middle half of your data, it gives you the interquartile range. So it is giving you Q3 minus Q1. And don't forget, Q3 is our 75% of bottom 75% of data. And Q1 is our first quartile, which is bottom 25% of data. So it is giving you overall 50% of your data. So interquartile means here is the correction. This is Q3, not Q1. So outlier, if we define outlier, so any value which is less than Q1 minus 1.5 IQR. So that means bottom 25% of your, like within 0 to 25% if the data which is outlier. And if you have Q3 to onwards, so if you remember the normal distribution, distributive data, so it looks like this. So if for instance your data is normally distributed, then here is your mean, which is your Q2, if you see it in terms of quartiles. So Q1 will be your Q2, Q3 will be 75% of your data, and Q1 will be your first 25% of your data. So it means if Q1 minus 1.5 IQR, if you will find, so IQR is Q3 minus Q1, which is 50% of your data. It means way shorter values you will get. If something, it will be here. So it means Q1 minus 1.5 IQR value will exist in it. I'm using the symbols belongs to this side. So if you have outlier value on the right side, so it means somewhere here it will exist Q3 plus 1.5 IQR. So for instance, like you have a data points from 1 to 39, and I'm adding 1.1055, so it is way long, way far off your other values that are in your data set. So that is outlier value, that is way off from your data set. So if you want to find it out, which one is it, the outlier in the existing data, so here is the formula. If it exists in this section, so it means that is your outlier value. So here is an example. If your data, for instance, you have even numbers of given data is given, then how you can find your quartiles. So don't forget, Q1 is your bottom 25% of your data, sorted data, and Q2 is the middle half of your data, and Q3 is your bottom 75% of your data. So first thing is very important, sorted data. It means it has to be in an increasing order you have to write. So this is not sorting. This is why in the first step, I'm going to write it down in a sorted way. So how many number of values are in there? 1, 2, 3, 4, 5, 6, 7, 8. 8 values are there. So it's very easy to find the middle of your data, like median of your data. It's very easy to find out. So if you find the median of the data, so that is giving you Q2. So these are 8 values. So median will be somewhere here. So it means I don't know what value is it. So this is why I'm taking the average of these two middle values. So 10 plus 15 divided by 2. So this is giving me Q2. So if you want to find Q1, so Q1 is the the median of your half data, which is from Q2 to the first value. So if you find these the median of these four values, so this will be your Q1 here in the middle of these two values. So again, you will take the average of these two values, 3 and 6. So this is giving you Q1. And half of your data lies on the right side, which are four values. So if you want to find the 75% of your data, where does it lie? So you need to take the median of the last portion, which is 50%. So four values are there. So median will be here. So this will be your Q3. So it means it will be middle of these two values. So you will take the average of these values. So this is giving you Q3. This is how you find the quartiles. So if you have odd number of values, then what you will do, I just have added one more value after it. So this is what it looks like. So if I will sort it, so 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the 9 values. So first thing is step one, you have to sort it. So sort it. So it means 1, 3, 6. You have to write it in increasing order: 6, 15, 10, 21, 28, 36, and 29. So sorry, 39. So these are how many values it has? 9. So this is step one. Step two, you have to, very easy to find. You first, I would suggest you to find Q2, which is very easy. You can just find the median of your given data values. So how you can find the median of your data values? This is four values are on your right, four values are on your left. So this is your median value. So this is Q2, excuse me, is 10. And if you have to find Q1, so what it will be? So this is giving you, so you need to find out the median of five values, these five values. And if you find Q1, so this is your median of these values. And similarly, you can find out for Q3, that is your giving you the 75. This is your giving you the 75%, and this will be giving you the Q1%. All right. So if you have to find the Q1, how will you find it? These are the five values on your this one. So you will, this is the middle value or is 6. So this is your Q1. And if you have to find Q3, so the five values from here, you can find this is your Q3, which is 28. The upper half values, the median of the upper lower half values, sorry, the sorted data, the bottom half, 75% of your data, you will find out. So from 10 to 39, I can find the median. So this is giving me 28. So this is step 4. This is how you will find the median for odd and even number of your data. Okay, so Q1, Q2, and Q3 are important for us because you can see it in also graphical form. If you are to find the box plot, like this is the graphical summary. This gives you the graphical sketch of 5-number summary. So 5-number summary is what you have, is just like quartiles. In the given data, you can have minimum data, maximum data, and also quartiles in it: Q1, Q2, and Q3. If you make a graph of these values, then that graph will give you the box plot. If you, for instance, you are making for first example, first example, where is that? This one, 1, 3, 6, 10, 15. Let me write it down. 1, 3, 6, 15, 21, 28, 36. 21, 28, and 36. So what you have to do, you have to make it in a graphical form. So the minimum value is 1, maximum value is 36. And if you find Q1, Q1 is, what is the value of Q1? Sorry, did I write all the values? One second. Oh, 15, 21, 136, 10. I didn't write it down. Yes, it has 10 also. So if you find Q1, so what is the value of Q1? Q1 we find, which is in this case 4.5. Q2 is 12.5. And Q3 is, I think, 14.5. 24.5, sorry. 24.5, right? And maximum value you have 36. So first you have to do, like, um, you make the units of the x-axis. Let's say I'm making a scale. Here is my minimum value 1. Because my maximum value is 30, so I'm dividing it into, let's say, 10. So this is my 10 unit. This is my 20 unit. This is my 30 unit. And this is my 40 unit. So here 36 will lie approximately, it will be here 36, right? So right above, I'm writing it, I'm making a line on 36. The minimum value is 1, which is here. So right above, I'm making a line on it, right? So I need to find out what is my Q1. Q1 is 4.5. So it means it will lie right in the middle and little bit before. So here it will be, because 4.5 will be here. 12.5 approximately, it should be this value. And 24.5 approximately, it will be here, 24.5, right? So if I am making a dot right above on these points, so what I have to do, so from minimum point to Q1, I will join and I will make a box from here. This is the box. And that box will go till you will go to the, you will lead it to Q3 point. So Q3 point, and then you will make a box there. And where is your middle value? The middle of the data, which is median of your data, which is Q2. Again, you will make a line on that. And that box again, you will join with the maximum value. So this is how you will make the box plot. So the box you make in between Q1 and Q3, and Q2 will tell you where is your median of your data. So this is the explanation of graphical sketch of quartiles if you want to see. So this is how we make it, the box plot. And that's it. So this was our last lecture that I had to finish. Now we will discuss about our next topic, which is probability.